In this part of the video, I'm going to show you a double-threaded linked list. So the idea of doubly threaded linked list, let's take a look. So I'm trying to model student, assuming student object only has the ID and the GPA part. And I have 3 student objects, and in this doubly threaded linked list, look at this is the data part. So this is the data part, and it has a next pointer, and this next pointer is according to ID. So the next pointer will be pointing to this node, got G40 there, and the next pointer will point to G60 there. So this first thread, the blue thread, is sorted by is organized by ID. And this head by ID point to this G20 node. And similarly, we have a head by GPA. The first one point to this one because GPA got a 3.5 there. Head point to this node. And the next pointer, we have another next pointer called next by GPA will point to 3.8 node, this node. And this pointer will point to this node where the GPA is 4.0, and that's the end of the second thread. So let's take a look at the node structure here. The structure for the node contains 3 parts: the data part, and the next by name part, the next by GPA part. So the doubly threaded linked list isn't a doubly linked list. Usually when we say doubly linked list, that means a node keep track of where the next node is, so it has a next pointer, and keep track of a previous node. So that means you also have a previous pointer. But here we don't keep track of the previous pointer. You could keep track of the previous pointer, but to make it simple here, we only keep track of where's the next node. And but this next pointer, we got 2 of them. And imagine you could have more than 2 of them. You can have 3 or 4 or 5 of them because we are trying to keep track of different order. So if I'm trying to keep track of ordered by name and ordered by GPA, I can design 2 separate next pointer. And when you have 2 separate next pointer, let's take a look at the list. You're going to have 2 separate heads here, head by name and head by GPA. Imagine if you're keeping track of 3 different ordering, you're going to have 3 different next pointer, and you're going to have 3 heads for this linked list. So that's the idea of doubly threaded linked list. The good thing about this data structure is we don't duplicate data here. And think about the alternative. The alternative, you could be doing something like this. You say, oh, I want to keep track of 2 different order. Then how about, let's just do it this way. This is one linked list. And this linked list is, let's see, ordered by ID. So this is 10, this is 20, this is 40. Okay, and I have another linked list. And this linked list is ordered by GPA. And here you have the data again with different GPA. You see, this approach of keeping track of 2 different orders, ordering by 2 different linked lists, the downside about that one is you duplicate your data here. So you see your data object is contained in this set of nodes and this set of nodes. And if you don't want to duplicate data, it should be one way, like not duplicating the data, but keep track of 2 separate linked lists. So think about this. You could have, like, instead of putting data item here, you're putting pointer to data. And how about we say this one? And could look like this. Could look like this. Could look like this. Let's see. So you see, this way you have one set of data objects, but makes a linked list to only contain pointers to the real object. This way you only have one set of objects. That's fine too, but for our lab 1, you really need to implement something called a doubly threaded linked list. So instead of keeping track of two separate linked lists, we have one linked list with two heads and two next pointers, so two different threads, the blue one and the red one. The implementation shouldn't be very hard for you. So think about the insert operation. For the insert operation, now if I'm trying to insert some node, so let's say if I'm trying to insert a node, let's say this node is G80, how about G30 then? G30, and the GPA is, let's say, how about 2.0? If we're trying to insert such node, so the algorithm is still very similar. You first create a node, before you insert it, you try to create one. Then you're trying to resolve the first link, the first thread. So you can go through head by ID, exactly the same thing, do the traversing. So G30 is bigger than G20, so you keep on going, and you got to G40, you say, hey, it's supposed to be inserted here. Then you manipulate this blue thread, very similar to your linear linked list. Forget about the other thread, just manipulate this thread and link this node into that thread. After you're done, okay, work on your second thread. Work on your second thread, still start from head by GPA. So do the comparison. 2.0 is less than 3.5. Then you should insert it here. So link this node into the second thread using exactly the same algorithm. It's just you create. So the algorithm looks like you first create a node, then you go through the first thread, link it into the first thread, then go through the second thread, find the position and link it into the second thread. And when you try to remove something, you need to be careful. First disconnect this node from the first thread, then disconnect from the second thread. After that, you delete it. And similarly for the destructor, you should only delete a node once, not twice. That's the only thing you need to be careful about. Other than that, the algorithm is very similar to a plain linear linked list. Thank you.